During the Second World War, the Nazi regime sought different ways to advance its power by land, air and sea. While the troops fought on various fronts, groups of engineers were ordered to manufacture out of the ordinary vehicles. The designs were secret, the trials were carried out quickly, and the tests were launched without room for correction. From the early years, teams with direct access to command were formed to create mobile machines that did not exist in other armies. Some models came to be used, others remained as blueprints under military custody. They all had a single purpose: to build something that would provide an immediate advantage on the battlefield. New tanks were manufactured, planes with different engines, underwater vessels that did not need to surface, and weapons without comparison. Factories adapted, were hidden, and changed their materials according to what was needed. Although resources were scarce, the projects continued. Young technicians were pressured, prisoners with knowledge were forced, and plans were accelerated until the very last day. What kind of vehicles did they manage to build in their attempt to win the war? The armored monsters of the Third Reich, tanks, trains and war machines. During the years of the Second World War, the Nazi government invested heavily in land-based combat machines that not only fulfilled practical functions, but also stood out for their size and power. From gigantic plans to more technical models, the German authorities dedicated enormous amounts of materials and personnel to devices that pushed their factories' capabilities to the limit. The technical documents of the time record a long list of armored and ground combat vehicles that the regime attempted to build, many of them plagued with constant issues preventing them from functioning properly or being mass-produced. One of the most striking cases was the Panzerkampfwagen Maus, a machine that took the concept of a heavy tank to the extreme. Its development began in May of 1942, when the order was given to construct a vehicle that would far surpass existing models in armor and size. The company Porsche was in charge of the project, and by January of the following year, the basic design was already completed. The Maus was conceived as a giant that would carry a 128mm cannon accompanied by a secondary 75mm gun. By June of 1943, the first complete and functional chassis had already been assembled, reaching a height of 3 meters and 60 centimeters and weighing approximately 188 tons. During initial tests, this colossus demonstrated a frontal armor thickness of 200 millimeters, side armor of 180, and an even more protected turret that reached 240. Its propulsion system consisted of a Daimler-Benz MB 509 engine combined with an electric transmission that allowed it to move slowly as long as the terrain permitted. Even so, its practical possibilities were minimal. The enormous weight made it impossible to cross standard bridges and left it entirely dependent on very specific conditions. In mid-1944, a second unit was built, this time with the turret mounted, but it never reached the combat front. Only 2 were manufactured, and 1 was captured by Soviet forces at the end of the conflict. Its existence remains a symbol of how far engineering could be pushed without considering tactical viability. In parallel with the Maus, another colossal model was conceived, the E-100. This vehicle was born within the Entwicklung standardization program, which aimed to unify the parts and structures of German tanks to facilitate their production and maintenance. The E-100 was intended to be the next step in that scale of heavy vehicles, with a design that integrated torsion bar suspension and enormous road wheels. Its weight would exceed 130 tons, and it was planned to use a modified Maybach HL 230 P30 engine, although more powerful alternatives were also considered to compensate for its size. The turret design was initially very similar to that of the Maus and integrated a 128mm main cannon. Despite the effort to equip it with dense armor and comparable destructive power, one of its fundamental problems was its limited mobility. Although on paper it was estimated that it could reach acceptable speeds for its mass, the most optimistic calculations gave it just over 20 kilometers per hour, and that only under controlled conditions. In addition, its gigantic silhouette made concealment nearly impossible and complicated movement on the battlefield. The chassis of the first prototype was completed in the workshops of the Adler Company around mid-1944. However, it lacked both armament and a functional propulsion system. Initial tests were conducted with a provisional engine that allowed only limited and low-speed movement. The advance of Allied troops through German territory interrupted any possibility of completing it. By April of 1945, the incomplete vehicle was found by American soldiers. It never operated in combat. Unlike the Maus, which was designed as a unique piece, the E-100 was part of a broader idea focused on creating a family of standardized tanks. Nevertheless, the weight of the conflict, the lack of resources, and the enormous logistical limitations prevented the project from progressing beyond that initial phase. Although these two examples represent the extreme of German engineering applied to land warfare, they were not the only large-scale vehicles used or envisioned by the regime. Another branch in the development of armored units focused on models that, while not as massive, were designed for missions involving zone control, armed transport, or troop support in difficult areas. In this context, another type of imposing structure emerges. Less conventional but extremely effective in certain regions of the front, the armored trains. These compositions were created as mobile solutions for patrolling, defense and attack along railway lines. Germany adapted both civilian wagons and models specifically designed for combat. The trains were reinforced with thick steel plates and equipped with tank turrets, anti-aircraft guns and long-range artillery pieces. Their main mission was to ensure security along rail segments exposed to sabotage or enemy incursions, especially in occupied areas of Eastern Europe, where supply lines were constantly under attack. Each wagon served a specific function within the convoy. Some housed infantry units, others were dedicated to communications, command, or even repairs. The armor was adapted to the type of threat they faced and varied according to geographic location. For example, in Poland and the Soviet Union, the wagons often had additional reinforcements due to the constant risk of ambushes. The personnel on board were trained to operate both from inside the train and in rapid disembarkation maneuvers. The weaponry integrated into these trains could vary considerably. Some incorporated turrets taken from Panzer IV models, 88mm cannons, heavy machine guns, and even rocket launchers and large-caliber railway guns. Each wagon was connected by protected passageways that allowed soldiers to move without being exposed to enemy fire. This configuration enabled the trains to maintain a steady rate of fire without the need to halt their advance. In specific scenarios such as the Balkans or the Eastern Front, these mobile formations proved useful as centers of fire and command. Their size and presence deterred surprise attacks and helped keep essential logistical corridors open. At times, they were sent directly to unstable sectors in order to reinforce the security of strategic railway lines or support the efforts of occupation units. However, their effectiveness gradually declined. Starting in 1944, Allied air superiority turned these massive structures into vulnerable targets. Many of them were destroyed or withdrawn from service due to their limited defensive capability against bombings. Only a few examples, equipped with anti-aircraft weaponry and additional reinforcements, continued operating in high-risk environments. The rest were dismantled or ended up in enemy hands. Some models came to serve complementary roles beyond combat. Units were identified that were equipped with radio systems, film projection equipment, and personnel dedicated to boosting morale on isolated fronts. These trains were used as propaganda tools, aimed at maintaining troop morale and reinforcing the narrative of power that the regime sought to project. Among the Third Reich's land inventory were also tracked and half-track transports, designed to mobilize personnel, tow artillery pieces, or traverse difficult terrain. These vehicles were essential for maintaining troop mobility. One of the most widely used models was the SD KFZ 251, deployed in multiple theaters of operation. The design combined front wheels with rear tracks, which ensured adequate traction without sacrificing speed. Some of these transports were armed with machine guns or anti-tank cannons, while others were adapted as ambulances, command posts, or liaison units. Their operational flexibility made them highly valuable tools, although their limited protection left them exposed during prolonged engagements. The diversity of land vehicles deployed by Nazi Germany reflected not only an ambitious technological approach, but also a tactical response to the need to face different types of terrain and combat. From massive structures like the Maus and the E-100 to armored trains and multi-purpose transports, the regime sought to cover all possible situations with specialized machines. In each of these developments, a common pattern can be observed: the intent to make an impact not only through firepower, but also through the size, complexity, and visual effect of these creations. That commitment to the grandiose, the imposing, and the novel formed part of the Third Reich's military imagination. Many of those projects ended up shelved or destroyed before entering effective service as a result of the operational limits imposed by the reality of the conflict. The Third Reich's aerial laboratory prototypes fighters and extreme missions. After the massive development of colossal land machines, the next phase of the Third Reich's warfare innovation shifted toward aerial dominance. The Nazi authorities knew that control of the skies could tilt the course of the war, which is why they launched increasingly daring programs. From jet fighters to experimental bombers, German aviation became a laboratory for risky technologies that, although in many cases failed to achieve their strategic goals, marked a turning point in military aircraft design. One of the most notorious cases was the Messerschmitt Me 262, the first operational fighter powered by jet engines. Its development began before the start of the conflict, but a lack of resources and the pressure to keep the Luftwaffe operational delayed its entry into service. It wasn't until 1944 that the first units were ready for real missions. The Me 262 reached speeds of over 800 kilometers per hour, easily surpassing any Allied aircraft of the time. Equipped with two Junkers Jumo 004 turbojet engines, its climb rate, maneuverability and firepower made it a formidable rival in one-on-one combat. In its first appearances, it managed to shoot down several enemy bombers before they could respond. However, its technical advantages did not translate into air superiority. The Me 262 was vulnerable during takeoff and landing, moments when Allied fighters systematically hunted it. In addition, the engines required constant maintenance and had an extremely short service life, which reduced its operational availability. On top of that were the frequent bombings on factories, which hindered large-scale production. Another obstacle was Hitler's decision to convert the Me 262 into a fast bomber, instead of limiting it to fighter duties. That modification caused additional delays, design adjustments, and a loss of time that could never be recovered. Despite everything, this aircraft became a symbol of what could have been a revolution in aerial warfare if applied with better planning. In parallel, the Heinkel He-162 project, also known as the Volksjäger, was a desperate response to Allied air superiority. The idea was to build a cheap, fast-to-produce jet fighter piloted by Hitler Youth teenagers with minimal training. The design had to be simple and lightweight, which is why non-strategic materials like wood were used for much of its structure. The He-162 had a single BMW 003 engine mounted above the fuselage. In theory, its speed and agility made it suitable for quick interceptions, but in practice the problems were obvious. Many units crashed during testing due to structural failures or pilot errors. Its cockpit was narrow, hard to control, and the limited visibility increased risks in combat. When it began operating in early 1945, it was already too late. Allied troops were advancing on all fronts, and airfields were being bombed relentlessly. Although some squadrons managed to take off and briefly engage enemy bombers, their actual impact was minimal. Even so, the He-162 clearly reflects the final attempt to keep the war in the air by any means possible. Another notable initiative was that of the Horten Ho 229, an aircraft that broke with conventional shapes. Its design was a flying wing, without a defined fuselage, which reduced its radar profile. Although radar at the time was not yet a fully reliable tool, the creators of the Ho 229 were already thinking about how to evade it. This early concern led many to consider this plane a precursor of modern stealth technology. The Ho 229 was also powered by two Junkers Jumo 004 jet engines and could reach speeds of 600 kilometers per hour. The first prototype carried out test flights in late 1944, but an accident during one of them delayed the program. Only a few units were built, and none participated in actual operations. When the Allies approached the facilities where it was being assembled, they rushed to capture the remaining parts, some of which were sent to the United States for study. The design of the Ho 229 was based on advanced aerodynamic calculations, and its structure used composite materials, which was unusual for the time. Its triangular shape with no vertical tail, along with the internal positioning of the engines, offered an advantage in terms of air resistance. Although it was never tested in combat, its silhouette anticipated technologies that decades later would be applied in aircraft like the B-2 Spirit. Beyond conventional fighters, unmanned or suicide mission aerial vehicles were also conceived. One of the most radical cases was the Bachem-Bar 349 Natter. This small manned rocket was intended to be launched vertically from a fixed platform, rapidly ascend toward formations of Allied bombers, fire a burst of rockets, and then allow the pilot to escape by parachute before the rest of the craft crashed. The Natter was mostly made from low-cost materials and could be constructed in a very short time. The pilot required little training, as nearly the entire operation was automated. However, initial tests revealed critical flaws. One of the flights, carried out with a real pilot, ended in tragedy when the separation system failed and the pilot died upon crashing into the ground. The idea behind the Natter responded to the desperate attempt to stop the constant bombing over German territory, but its implementation was as risky as it was limited. It was never used in actual combat, and only a few units were built before the collapse of the regime. Even so, the concept of vertical takeoff, automation, and the use of guided projectiles places it as a direct precedent of technologies that would emerge in the post-war era. While the most advanced models required major investments and complex technical knowledge, the regime also leaned on more practical solutions that could be executed quickly. One of the most notable examples was the Focke-Wulf TAR-152, an evolution of the popular FW-190, which had proven to be an effective fighter during different stages of the war. The TAR-152 was specifically designed to intercept high-altitude bombers. It was equipped with a high-performance Jumo 213E engine, allowing it to reach altitudes above 12,000 meters and speeds approaching 750 kilometers per hour. Its elongated fuselage and extended wings improved high-altitude stability, making it a respectable rival for Allied escort fighters. In the few missions it managed to complete before the end of the conflict, the TAR-152 demonstrated impressive performance, surpassing its enemy counterparts in several aspects. However, its arrival came too late. With fewer than 50 units produced and an air front completely dominated by the Allies, its capabilities were not enough to change the course of events. Another high-performance proposal was the Dornier-Du 335, nicknamed Pfeil or Arrow. This two-seat aircraft featured an unusual twin-propeller configuration, one at the front and another at the rear. This setup, known as push-pull, reduced air resistance and gave it a maximum speed exceeding 700 kilometers per hour, making it one of the fastest piston-engine planes of the war. Its design allowed for remarkable acceleration and excellent maneuverability, despite its size. In addition, it incorporated an ejection seat for the pilot, an advanced innovation for the time. The Du 335 was intended both as a heavy fighter and as an interceptor, and some models were adapted for reconnaissance. Despite its exceptional performance, production was extremely limited. Only a few dozen units became operational before the war ended. The idea of combining speed, firepower, and versatility in a single aircraft reflected the intention to regain lost air superiority, but as happened with many other models, bombings on factories, resource shortages, and the pressure of imminent collapse prevented the Du 335 from being deployed in significant numbers. On a more experimental front, the concept of the Lippisch P-13A emerged, a radically designed aircraft aimed at taking advantage of the aerodynamic principle of delta wings. The project proposed an airplane with no visible moving parts, powered by a jet engine fueled with coal dust. This idea was intended to bypass the shortage of liquid fuel in the final stages of the conflict. The fuselage of the P-13A was triangular, with no conventional rudders, which implied a completely different control system from traditional fighters. Scale models and some wind tunnel prototypes were built, but no actual flight was ever carried out. Nevertheless, its configuration later influenced the development of supersonic aircraft during the Cold War. Other unconventional proposals were also considered, such as the Blohm and Voss BF-141, an asymmetric reconnaissance aircraft that broke with the rules of aerodynamic symmetry. This model had an off-center command gondola, located to one side of the engine and wings. This layout allowed the observer an unobstructed view of the terrain from the glazed cockpit. Although the first flights were successful and maneuverability was acceptable, problems with the allocation of more powerful engines prevented the project from advancing. A few units were produced, but it never became a standard aircraft. Its peculiar shape remains a subject of study for engineers and aviation enthusiasts. Another singular initiative was that of the Fieseler Fi-103, better known as the V-1, which, although not an aircraft in the traditional sense, did serve an aerial offensive function. It was a self-propelled cruise missile that could be launched from ground ramps or even from modified bombers. The V-1 flew at a constant speed and produced a characteristic buzzing sound due to its pulse jet engine. Its margin of error was high and its explosive payload limited, but the psychological impact it generated in British populations was considerable. The first successful launch occurred in 1944, and for several months British cities were targeted by these projectiles. Although many V-1s were shot down by fighters or anti-aircraft systems, a percentage managed to strike urban areas. The V-1s represented a rudimentary form of automated warfare, and their low production cost allowed hundreds to be manufactured in a short time. Beyond their tactical effectiveness, the existence of these weapons signaled a radical shift in the concept of combat. It became possible to strike without directly exposing pilots or deploying large fleets. Amid the total collapse of the front, German engineers continued to develop unconventional aerial concepts. One of the strangest projects was the SAC AS-6, an experimental circular aircraft that attempted to take off like a conventional plane, but featured a structure more similar to a disc. The design was based on rudimentary ideas of lift, generated by rotating bodies, although its tests clearly showed it was unviable. It never achieved a successful flight and was relegated to a technical curiosity, with no future beyond occupying space in the archives of failed prototypes. Another singular model was the DFS-346, conceived as a supersonic reconnaissance aircraft intended to fly at high altitudes. Its shape was elongated, with swept wings and an extremely slim profile. The project proposed that the craft be towed by another plane until it reached a considerable altitude, from where it would separate and continue its flight at high speed with the help of rockets. The structure included a pressurized cockpit and special controls adapted to extreme speeds. Although the design was captured by the Soviets before completion, they resumed the concept years later and tested it in their own aerodynamic research program. In an effort to reinforce strategic reach, the Messerschmitt Me 264 project emerged, a long-range bomber informally known as the America Bomber. It was designed to cross the Atlantic, strike American soil, and return without refueling. It had 4 engines and a structure optimized for long flights. Initial tests with the prototype showed potential, but shifting priorities and a lack of resources prevented it from advancing beyond the development phase. Only a couple of units were built, none of which ever took part in real operations. Aircraft designed for tactical observation missions were also developed. The Fieseler Fe-156 Storch was a lightweight, extremely maneuverable model, capable of taking off and landing in confined spaces. Although it had no futuristic appearance and was not meant for direct combat, its versatility made it a key tool for liaison tasks, medical evacuation, and close reconnaissance. Its high wing and fixed landing gear provided outstanding stability, allowing it to operate in improvised fields or mountainous terrain. It was one of the few aircraft used extensively from the beginning to the end of the war. Within the category of innovative bombers, the Arado R-234 stood out, the first jet-powered bomber in history. This aircraft used 2 engines mounted under the wings, reached speeds of up to 700 kilometers per hour, and operated at altitudes that made detection difficult. Its structure was sleek, with a fully glazed cockpit in the front position and retractable landing gear. Its main function was reconnaissance, but it was also adapted for precision attacks. Its speed allowed it to evade Allied fighters, although its payload capacity was limited. Despite that, it became one of the most advanced models in the German arsenal. One of the most extreme concepts was the Zeppelin Rammer, a project that combined a rocket plane with a direct impact strategy. The craft was launched from another aircraft or from the ground, ascended using a rocket engine, and was armed with front-facing cannons. Once the ammunition was depleted, the pilot was supposed to ram enemy bombers with a reinforced section of the plane. Although it included a system to allow the pilot to eject before impact, the mission remained extremely dangerous. It never advanced beyond the design phase, but it reflected the level of desperation present in the final stages of the conflict. The Heinkel. He-274 was another attempt to build a high-altitude bomber, this time derived from the He-177 but with a more modern structure. It incorporated high-power engines, a pressurized cockpit, and a streamlined fuselage. Its goal was to operate above the reach of most enemy fighters, carrying out deep bombing missions. The prototype was nearly completed when Allied troops occupied the production facility in France. Despite its advanced state, it was never used by the Luftwaffe. Among the lesser-known designs was the Junkers EF-128, an advanced proposal for a high-performance fighter with forward-swept delta wings. It was part of the emergency program launched in 1945 to produce next-generation jet fighters in record time. The EF-128 was never built, but the conceptual blueprint proposed aerodynamic solutions that anticipated post-war developments. The forward-swept wings, dorsal air intake, and recessed cockpit reflected a continuous search for flight efficiency and relative stealth. Ideas were also conceived that extended beyond Earth's airspace. The Silbervogel, or Silver Bird, was a theoretical project for a suborbital bomber capable of taking off with the help of an acceleration rail, reaching the upper atmosphere and bouncing along it in a gliding motion to strike distant targets. The concept was developed by Eugen Senger and was so far ahead of its time that it resembled a spacecraft more than an airplane. Although it was never built, some of its technical principles influenced later research on hypersonic flight and intercontinental ballistic missiles. There was even a proposal for the development of specialized amphibious aircraft for infiltration. The Blohm & Voss BV-222 was a large flying boat, used mainly for transport along maritime routes. Its cargo capacity and range were remarkable, but what stood out most was its enormous size and reinforced structure for operations in remote areas. Some versions were adapted for naval reconnaissance and medical evacuation tasks. Despite its volume, it managed to operate in hostile environments without major issues. Some engineers, having exhausted conventional options, turned to unorthodox combinations. The Heinkel He-162E, for example, integrated a jet engine with a piston engine in an attempt to combine the best of both worlds. The intention was to achieve greater range with one system and explosive power with the other, but testing never progressed to an advanced stage. Time, logistics, and military pressure nullified any chance of implementation. These projects, though scattered and of varying feasibility, demonstrate a constant obsession with pushing the limits of conventional aviation. The Third Reich intensified its efforts in prototypes, tests, and designs ranging from the functional to the extravagant, leaving behind a technical legacy that, while it did not determine the outcome of the conflict, did influence the future course of military and aerospace technology. The secrets of the Nazi ocean, submarines, suicide missions, and unique prototypes. While the Third Reich's aerial offensive faded in the skies and ballistic experiments advanced on solid ground, a third technological front was quietly developing beneath the surface of the sea. Naval warfare was not new to Germany, but the regime aimed to transform its submarine capabilities with faster, more efficient, and harder-to-detect designs. As Allied convoys reinforced their defenses, German Naval Command sought radical solutions to regain the initiative in the Atlantic and beyond. The most notable example of this technical ambition was the series of submarines known as Type 21. These submersibles represented a complete leap from their predecessors, both in underwater speed and in autonomy and offensive capability. The development of the Type 21 was neither gradual nor limited to prototypes. It was planned as a mass production series intended to replace most earlier models. Its hull was longer and more streamlined, allowing for much more stable and faster underwater navigation. One of its main innovations was the incorporation of high-capacity batteries that powered strong electric motors, enabling them to remain submerged for extended periods without needing to surface. Unlike traditional U-boats, which operated mostly on the surface and only submerged to attack or escape, the Type 21 was designed to function almost entirely underwater. This shift completely changed the rules of submarine warfare. In addition to speed, surpassing 17 knots submerged, far superior to any submarine of the time, these models were equipped with a rapid torpedo reloading system. Within minutes, they could launch several salvos, greatly increasing their chances of sinking enemy ships before being detected. They also featured improved sonar, automated control systems, and a lower conning tower designed to reduce surface silhouette. The original intention was to manufacture hundreds of these submarines to re-establish control over the Atlantic, but logistical difficulties, bombings of shipyards, and material shortages prevented that goal from being realized. Although more than 100 were completed, only a few units entered service before the total collapse of the regime. Those few operational examples did not have enough time to make a strategic difference, although they did demonstrate that Germany was one step ahead in submarine technology. Alongside the Type 21, a smaller version was developed, known as the Type 23. This class of submarine was intended for coastal missions, especially in the North Sea and the English Channel. Its reduced size allowed for faster construction, and like its bigger brother, it was designed to operate almost entirely submerged. It had room for only 2 torpedoes and a minimal crew, making it ideal for short, precise attacks near enemy shores. The maneuverability of the Type 23 was remarkable. It could travel at surprising speeds in submerged mode and had a very low acoustic signature, making detection difficult. These models were employed in the final phases of the conflict, and although in limited numbers, they managed to sink several Allied merchant ships in record time. The crews who operated them praised their silence, stability, and ease of handling compared to earlier classes. However, as with other advanced projects, the Allied advance by land and air ultimately neutralized any technical advantage. The ports from which these submarines were to operate were constantly bombed or in enemy hands, and training time for new crew members was insufficient. Although the Type 23 models showed promising results, the disorganization at the end of the war severely limited their actual deployment. These 2 classes of submarines represented Germany's last attempt to regain maritime dominance. Although they came too late to have a decisive impact, many of their technological advances were studied and adapted by the victorious powers after the conflict. The United States and the Soviet Union made use of the blueprints, captured prototypes, and the experience of German engineers to advance their own submarine programs in the years that followed. But the Third Reich's advances in the naval field were not limited to large and sophisticated models. In the later phases of wartime development, German strategists promoted more extreme solutions, including tiny vessels for suicide missions or targeted sabotage. These projects were a direct response to the loss of control over the open sea, and their deployment involved maximum risk, both for the operators and for enemy naval infrastructure. As German forces lost ground on all fronts, Naval High Command decided to bet on smaller, cheaper, and easier-to-hide craft. Thus began the era of midget submarines, designed for quick-strike operations, sabotage, or infiltration of well-protected ports. These devices were not intended to replace the large U-boats, but to serve as tactical support in specific short-range missions. One of the best-known models was the Biber, a one-man submersible that barely exceeded 9 meters in length. Its design was extremely basic: a simple structure, 1 torpedo on each side, and a small compartment for the lone crewman. Despite its fragility and limited range, hundreds were manufactured in a short time. These mini-submarines were used primarily in missions against British ports or ships anchored near the coast. The Biber had serious drawbacks. Its maneuverability was limited, its navigation systems were rudimentary, and the operator's visibility was minimal. Many sank before even reaching their targets, either due to technical problems or the inexperience of their pilots, who often received only a few weeks of training. Despite its flaws, the authorities continued mass-producing them due to their low cost and ease of assembly. A more advanced proposal was the Seehund, a 2-man midget submarine that corrected several flaws of the previous model. Although still small, its propulsion system was more reliable, it featured more precise navigation instruments, and its autonomy allowed for longer operations. The Seehund carried 2 torpedoes and operated at greater depths than the Biber, making it harder to detect. The first Seehund units went into action in the winter of 1944, targeting maritime routes in the English Channel. Some of these vessels succeeded in striking enemy ships, but their numbers were insufficient to alter the course of events. Nevertheless, the strength of their hull, agility, and low profile made them one of the most effective German naval vehicles of that final stage. Even riskier proposals emerged, such as the Molch, a 1-person mini-submarine originally conceived as a training device. Over time, it was modified to carry out real missions, though its limitations were evident. Its shallow operational depth, lack of defensive systems, and slow dive speed made it extremely vulnerable. Even so, it was deployed in actual missions in coastal waters. Another peculiar design was the Neger, a manned torpedo craft consisting essentially of a turret with a sight and 2 torpedoes mounted underneath, one functional and the other used as a transport mechanism. The pilot was placed in a sealed compartment atop the guide torpedo, with no capability to submerge below the surface. This system made it highly vulnerable to any form of attack, but also allowed it to silently approach anchored or slow-moving enemy ships. Operators of the Neger were practically kamikazes. The survival rate on these missions was extremely low. Many did not even return to the launch point. Despite this, some of these devices succeeded in sinking Allied ships, which encouraged the regime to continue their production. The fact that someone agreed to pilot one of these crafts reflected just how deeply desperation had gripped the Third Reich's navy. Additionally, improved versions like the Marder were developed, which could submerge briefly and escape after launching the torpedo. Although conditions remained equally precarious and the success rate continued to be low, the Marder represented a slight technical advancement over the Neger. By the end of the conflict, these units were being launched by the dozens in nighttime operations, often without even a clearly confirmed target. These midget submarines as a whole never achieved sustained effectiveness. Despite a few isolated successes, the lack of training, poor coordination and Allied superiority in anti-submarine detection made their overall impact very limited. However, their existence reflects a phase of the conflict in which the regime relied on any available resource, regardless of risk or proven effectiveness. The most striking aspect of this stage was the combination of rudimentary technology with suicidal decisions. Many of the crew knew they would not return and still embarked with clear instructions to detonate their payload if captured. What had once been a technical war became, in the final months, a war of attrition with no return, in which each mini-submarine became a desperate gamble against time. Facing the growing military pressure from the Allies, the German Naval Command began to search for alternatives that combined the best of both worlds: surface speed and underwater concealment. From this need emerged hybrid marine vehicles, machines designed to move through the sea with greater versatility, while also being capable of evading surveillance systems. One of the most unique projects in this field was the Schwertwal, also known as the killer whale. This device combined concepts from torpedo boats and light submersibles. It had the external appearance of a small, fast vessel, but was capable of partially submerging for short periods. In theory, it was meant to approach enemy ships at full speed, launch its torpedoes, and then dive briefly to escape undetected. The problem with the Schwertwal was its fragility. It could not withstand deep pressure, its hull was too thin, and its diving capacity was so limited that it could only hide for a few seconds. Even so, its design suggested a possibility, bringing the mobility of a fast boat into the submarine environment. Only prototypes were built, and it never entered active service, but the concept would live on in later developments outside of Germany. Another similar attempt was the Delphin, a small, single-occupant submarine designed to be launched from a conventional U-boat or from the coast. Its aerodynamic shape and compact size allowed it to move at high speed underwater over short distances. It carried a light torpedo, and its mission was to approach an anchored target as closely as possible to launch a surprise attack. The Delphin was considered ideal for well-defended coastal areas, as its low acoustic signature made it difficult to detect. However, its operability was extremely limited. Its range was minimal, it lacked any defensive systems, and any engine failure would force the pilot to abort the mission or die from lack of oxygen. Most of the units built were only used in testing and never deployed in actual combat. Mobile platforms capable of transporting explosive charges to maritime installations were also developed. One example was the Linsen, an unmanned explosive boat that was remotely controlled from another nearby vessel. This craft was designed to travel at high speed toward its target and detonate on impact. Although it was not a submersible, its use in combination with midget submarines places it within this tactical hybrid category. Linsen attacks were typically carried out at night or in low-visibility conditions. The operator controlled the boat from another unit located a few hundred meters away, guiding it to the target using rudimentary systems. Success relied almost entirely on the element of surprise. In many cases, coastal defenses detected the craft before it reached its objective. Nevertheless, some attacks succeeded in damaging Allied ships anchored in poorly protected ports. In the same line of combined operations, the idea emerged of integrating mini-submarines with detachable explosive charges. These systems consisted of a small mother vessel carrying a bomb beneath its hull. Upon approaching the target, the charge was released via a simple mechanism and adhered to the bottom of the enemy ship using magnets. The submarine operator then fled before the programmed detonation. Although this method seemed functional on paper, in practice it proved extremely complex. Sea conditions, current speed, early detection by the enemy, and mechanical failures reduced its effectiveness. Only a few attempts were reported with partial success. Nevertheless, it illustrated just how far efforts went to exploit every possible variant in naval warfare, blending manned, remote, and automated systems. The development of these hybrid vehicles responded to a strategic reality. The traditional German Navy was completely outmatched. Unable to compete in numbers or tonnage, the only option was to design systems that broke the conventional rules of naval combat. The idea was to strike with devices so small and agile that they would be impossible to intercept in time, or so novel that the enemy wouldn't know how to respond. The result was a combination of technical creativity, material limitations, and extreme pressure to achieve immediate results. Many of these devices never moved beyond the experimental phase, but they marked the beginning of a new mindset in naval warfare: the surprise attack with light machines, autonomous or minimally manned, capable of striking quickly and disappearing before being detected. In the final stage of the conflict, with the fronts collapsing and the fleet reduced to its bare minimum, German command turned to extreme tactics in an attempt to slow the Allied maritime advance. Among them was the use of weapons controlled by human operators that functioned as living torpedoes. This was not an entirely new strategy, but it reached a distinct level of development under the Nazi regime. One of the most notable models was the manned torpedo High, which combined higher speed, medium-depth submersion capability, and improved maneuverability. However, by the time the model was ready for real testing, the military situation was already critical. There was no time for mass production, and only a few units were built, none of which were used in combat operations. Its design, however, was documented and preserved for later analysis. The logic behind these devices was influenced by constant pressure to achieve immediate results at low cost. There were no resources available to build large submarines or train complete new crews. For that reason, the focus shifted to minimal devices that required only a single volunteer operator, someone willing to face near certain death. This idea, though pragmatic in that context, generated intense ethical tension even within the German ranks themselves. In parallel with these systems, other attack methods were tested that also involved extreme risk for the operators. Among them were manually guided mines, small boats loaded with explosives that had to be placed near the hull of an enemy ship. In some versions, the operator had to remain on board until the moment of impact, making the mission a direct execution. The comparison with similar practices used by other powers, such as the kamikaze attacks in the Pacific, was inevitable. However, unlike those cases, in Germany voluntary sacrifice was not officially promoted as doctrine. In theory, operators were expected to return alive if the mission allowed it. In practice, that almost never happened. Many of the young men recruited for these missions came from inexperienced naval units, or were selected from personnel who could not be assigned to traditional vessels. They received short, intensive training, focused solely on the operation of the assigned vehicle. Often they had little knowledge of the overall tactical context. They were promised real chances of survival, something that was rarely delivered. Despite limited results, the regime continued to invest in these types of methods until the very end. Plans were even drawn up to attack Allied convoys using waves of human torpedoes launched from different coastal points. None of these operations were carried out due to a lack of time, equipment, and logistical conditions. Nevertheless, preserved documents and reports show that the commitment to these systems remained constant throughout the final months of the conflict. The manned torpedoes and suicide attack missions reveal just how far the naval capabilities of the regime had deteriorated. What had once been a fleet capable of threatening the entire Atlantic ended up relying on precarious devices with only one person aboard, no defense, no escape. The shift from great battleships to these minimal capsules marked the final chapter of a desperate strategy with no chance of success. When the German army surrendered, the Allies discovered remnants of more than 100 advanced warfare prototypes scattered across hangars, underground factories, tunnels, and port bases. Some aircraft had never been used, several submarines were only partially assembled, and other systems existed solely as blueprints. At facilities such as Nordhausen, Peenemünde, Wiener Neustadt or the Altausee mines, the team sent in uncovered hidden armed trains, tanks with twin turrets, aircraft without vertical rudders, and rockets ready to launch. More than 1,000 tons of parts, sketches and fuselage sections were removed and transported by the Americans, the British and the Soviets. Over 5,000 units of the V-2 model had been manufactured. Of the Messerschmitt Me 262, at least 1,400 units were in production when the war ended. Of the Type 21 submarine, fewer than 100 entered service. Most of these vehicles were destroyed, tested by other powers, or kept as evidence. Everything found revealed the same pattern, creating new forms of combat when there was no longer a path to victory. Each tank, each plane, and each torpedo was part of that final attempt to sustain a collapsing system. And if all of it was done under pressure and without resources, one final question becomes inevitable. What might they have achieved if the war had lasted just a little longer,